Application deployment is difficult. It is the one statement which I heard from so many engineers and students. But it is not true. It is the only thing which runs on some rules. And those rules are very simple. All you need to do is you need to learn those rules and you will become a very good DevOps engineer. So, in this part, I'm going to uncover those rules, those technologies, and those concepts so that you can become a very good engineer in your project or in your team, or if you want to do some solo work. So, without any delay, let's see what we are going to learn in this part. So, in this part, we already created one Docker Swarm YAML in the previous parts. So that Docker Swarm YAML is the one which we ran to deploy our application on the Linux platform. But that particular deployment thing is not completed because every time we need to do some manual steps to run that file to deploy our application. But it is not the way we do in the production or in any environment. We need a pipeline which do these all things for us, but we created the base, but right now we need to deploy it. So let's see what we are going to learn in this part to make it happen. Okay, so first of all, we are going to understand the flow of the CI/CD pipeline. It is the very basic block. We need to understand it, like what is the CI/CD pipeline, what is the flow of CI/CD pipeline, then we can fill that particular stages of flow. So in this way we can build our CI/CD pipeline. Then, after giving you the understanding of the CI/CD pipeline, I will give you a demo like what we are going to achieve in this particular video so that you will have a clear picture. Okay, so this is the part which I'm going to learn. Okay, the third thing is now set up the agent who will run the pipeline. This pipeline, what is this pipeline, and what is this agent? I will explain all the things, but this setup the agent is a very required part because it is the one who will do all the actions for us. Then actually we are going to work on this GitHub Actions. So we need to learn the basics of GitHub Actions too. So that thing also I'm going to teach you. And after it, we are going to create our Docker Hub repository. Why we need a Docker Hub repository? I will tell you that too. And I will give you all these steps visually so that you can understand, okay, why I need the Docker Hub, how can I create the Docker Hub repository, and how can I link it. Okay. After it, we are going to create our GitHub Actions. What is this GitHub Actions? There is no need to panic right now that you don't know, because I'm going to give you all the things from the very scratch so that you can understand that what these bullet points are and why I wrote it. So in the end, when these all things are there, then we are going to do some changes in our application for the zero downtime deployment setting. This zero downtime. So you ever heard like you are upgrading your application? So let's say you have an application which is already deployed, but you want to uh, push some patches into it, but you don't want your application to go down, so you are pushing your patches in a parallel way. In this way, you are going to get the zero downtime. But how we can configure it with our application, that I will show you. That I will show you. Okay. And then when we are done with all these things, then we are going to click a single button, and what it will do, it will deploy our application. Okay. And we will test it too. So this is the complete plan of this particular part. In this, you will become a master of this CI/CD pipeline so that you will have to know what are the things which I will tell you. Okay, so let's go with the understand flow of CI/CD pipeline. Okay, so before pushing into the CI/CD pipeline, let's understand the DevOps pattern. What is this DevOps? It is the development plus operational pattern. Why we need to learn it? Because it is the part which comes under the DevOps. So what this DevOps pattern do? So let's say you have something in your code repository and you push the code into the Git repository. Okay, it is the first step. When you have pushed your code into Git, then what will happen? It will run some test. it can be your PyTest, it can be your own modified your or some different framework test which is linked to your GitHub repository. So every time when you are committing a push, it will run the test. So when these tests will run, it will create a sanity report, and based on that sanity report, the reviewer, the one who is going to review your code, will get some confirmation that okay, whatever the code you have pushed is good enough and it is not breaking any functionality. Now I can review the code to make sure that okay, this code have uh, all the compliances, or this code do not have any hard coded value, or this code is structured properly. So it is the way this code push go from one end to second end, like from the submitter to reviewer. Okay. After the test, it will go for the Docker build. So let's think of it as a Docker build is we are going to create a image of our application. So when your application is successfully tested and merged into the main branch, so this main branch, what we are going to do is we are going to create a Docker image of that particular main branch. When we create the Docker image, now the second part is we have created the Docker image into our CI/CD platform, and now this particular image will be pushed to the Docker Hub. But why we need the Docker image? We need the Docker image because it is easy to deploy. We don't have to do all these settings at the platform where we are going to deploy our application. So what we need is we need the Docker image. We are the Docker image of our application. We are pushing this Docker image to the Docker Hub, and then we are going to pull that Docker image and deploy it into the platform wherever we want to deploy. It can be your cloud services, it can be your internal servers, or it can be anywhere. So this Docker is very good. Like it is used everywhere. And after the deployment, what will happen? Again, the test. The test is the part which will come every time whenever you are going to do some very uh, important thing. So, like you are developing, test is required. When you are merging, test is required. When you're deploying, this test is required. So, it is the real DevOps pattern which we follow in all the projects. It is not only for the one, it is for the all. Every single product or project which is developed inside a company will go through these phases. So, it is the upper part. Now, let's go a bit deep into it in the perspective of Docker Swarm. Okay, so right now we have a dev who is developing our code, and now the developer is pushing the code to the Git repository. Okay, it is the first part. In the Git repository, there is one main branch, or you can say master branch. And what developer do is developer always push their changes to a feature branch. Okay, the feature branch is a different branch which will be created from a master branch, or it can be like a new branch, totally new branch, which you want to integrate with the master or the main. So right now the developer created a branch, or developer just wrote some code, some feature, and that particular feature will go into some different branch that will be called as feature branch, and that feature branch need to be merged with the master or main. Okay, so it is the second step. Now the GitHub Actions come into the picture. So what this GitHub Actions is? GitHub Actions is like inbuilt CI/CD platform which is provided by the Git, and most of the companies moved from Jenkins to GitHub Actions right now because it have so many features. And but in Jenkins is also good. Like it is not totally removed. Like in every company, the Jenkins is also used, but this GitHub Actions is coming into the picture at every organization right now. So it is good to be at that technology which is mostly used by all. So what is this GitHub Action? What this GitHub Action will do? So let's say you have created a commit to be merged with the master branch, and your reviewer, the main person, that person just merged your code into the master branch. So now what GitHub Action will do, just think GitHub Actions as a machine, a separate machine who is watching everything. So what this GitHub Action will do, this GitHub Action will create a connection with a Docker Hub. And now what it will do in the application which you just like which have the new feature right now after the merge, this GitHub action will create the image, and this image will be pushed to Docker Hub after creating the connection. Now this GitHub this Docker Hub, sorry, this Docker Hub, this Docker Hub have your newly created Docker image. And now, what this GitHub action will do, it will initiate the Docker Swarm. It is a different machine who is watching everything, and now that particular machine is trying to do all the work one by one. First of all, it created the image and pushed it to the Docker Hub. And the second thing is it initiated the Docker Swarm. Now, what this Docker Swarm will do, this Docker Swarm will pull the Docker image from the Docker Hub, your newly created image. It will be pulled by the Docker Swarm from the Docker Hub, and it will be deployed at your application server. Again, this application server can be anything. It can be your internal server, it can be the server on the cloud, or it can be uh, hosted by some other services. It can be anything. So it is the part which is done by the GitHub action. The GitHub action is something who is taking the input from the one side and doing the actions on the second side. The second side is part the deployment, and the let's say the left side is for the coding part and the right side is for the deployment part. So GitHub action is in the middle. This GitHub action will watch like what is happening at the left, and if I get the instruction from the left side that okay, my code is ready, now you can go, then I will take that code and I will do all the process to deploy it. I will do all the things automatically. No any engineers need to do any single work in between that. Okay. So it is the one. Now the application server have your latest feature with your application and user can use it. So I guess I was able to provide you some information about the GitHub action, the CI/CD, and this is the CI/CD pipeline. The CI/CD is continuous integration and continuous deployment. So here what we are doing is whenever we are integrating something, we are deploying it on the go. And the user is the one who is using that particular feature or service, whatever we are releasing it. Okay, so it is the part where we just learned about the concept of CI/CD. The CI/CD is something we are watching for the integration, the code integration, and we are the CI/CD pipeline is responsible for the continuous deployment. Like I have some running deployment of my application, and again, I need to push the feature to the deployment so the user can use it. So it is the continuous integration and continuous deployment. So I guess it is the this part is clear. Okay. So now let's move to the second part. Let's see the steps to prepare your server. But what I mean by this steps to prepare your server. So here, this GitHub action, this GitHub actions is something which is doing all the things. But to do all the things, it need a machine. As I said, like this GitHub action is a machine, and everything need to be done on a server. Like all the things which we did manually, this GitHub action also need a machine to perform these all steps, like creating image, pushing the image to the Docker Hub, then using the Docker Swarm to pull the image and to deploy the application. So these all things will be done on a machine or and also by a machine, but the instructions will be taken from the GitHub actions. So we need a machine where where we are going to deploy our application. So for that only, we need to prepare a server. This server will connect it to the GitHub actions, and it will be in sync with some request response cycle, so that this GitHub action will monitor that machine. Okay, this machine is ready and I can deploy the application. And also this application server will watch the GitHub action for any further commands. So we need to create a setup between the application server and this GitHub action. So for that only we have these steps to prepare your server. So, okay, we are not going to just directly into the command prompt and do all the downloading and configuring. First, we will see the steps, then we will go there. Okay, so what are these steps? First, we are going to prepare the environment. As we are going to use the Linux, we are going to update its library, and we will install the required build essentials, which will be used by the GitHub action. Okay, so it is just the ins installation and upgrade part of your machine, and your machine will be on the Linux platform, because this Linux is used by most of the companies and it is reliable and configurable. Second thing is, after doing all the build essentials, we are going to enable the Docker. It means our machine should have the Docker, and this Docker should be up and running inside our machine. And also, it should have the Docker Swarm installed too. Okay. After it, we are going to download the GitHub Action Runner. It means I have a machine, but it is not linked with my GitHub Actions. So I need to download a client, and that client will create a link between the GitHub action and my server. So this client will take the instructions from the GitHub actions and do all the things into my application server. Okay, so it is the third thing. Now, configuring the runner. So we have downloaded it. Now need to configure it too. Okay, so we have the agent, but we need to configure it. Okay, and then after configuring it, we need to just run the agent. Okay, so it is very simple. All we need to do is we need to prepare our machine. We need we need to make sure that this Docker is running. Then we need to download the GitHub action runner. We need to configure it and just simply run it. So it is the process which we need to follow to make our machine workable. Okay, so let's see. Okay, so first we will do these things, then we will go for the second part. Okay, so for that, what I will do, I will simply come here and I will open my terminal. Okay, here it is. Fine. Okay, so let's just run few commands which we just discussed right now. So what I will do, first I will update my system and I will do the upgrade to all the essentials which I already have. So what I will do, I will just click yes on it, and okay, I'll skip this part to the end. Okay, so this part is completed. Now let's check if I have Docker installed or not, as I already have this Docker installed. So I guess it should give me the command output. Okay, this Docker is running. And if you are getting some issue while installing Docker, you can definitely ping me. Sorry, you can definitely ask me in the comments. I will definitely give you the answers. And it is very straightforward. You can search it, you can install it, and you can check whether it is running or not. Okay, so it is the first two things which we did. This Docker is enabled and I have updated my system. Now let's go for the other thing. Okay. So what I will do, I just need to update few more things. Like I need to install this Git and all the required build essentials for my Linux platform. So that thing which I will do here. Okay. So again, it will ask me for my password. Okay. I will give it. It should not take much time. So let's wait for a few minutes. Okay. It is done. So now this system is ready to accept few more things. Okay, now let's go for the uh, another thing, which is this one. Okay, so let me just check where it is installed. It is installed at home Kshitij action runners. Okay, fine. Now I will just download the file, which is this, and all these commands which I am running here right now, I will provide you into the description so you can directly copy, paste, and execute it. If you are watching like after so many months or years, if this video reached you, then definitely check for this particular link which I'm pasting here, and it is also in the description. Okay, so what I will do, I will just download it. Okay, so it is downloaded. Now what we need to do is just let's see, and we need to untar it. So xzvf, and it will untar all the things, and it will have these scripts which will be used to link this particular Linux machine to your GitHub action. Okay, so let me do the ls. So it have this config.sh. Now we need to link this config.sh to our Git repository. So what I will do, I have already this Chrome opened here, and I need to go to the settings. Okay, it is the settings, and then inside the settings, do I have the Linux? Okay, actions. Okay, it is the actions, and inside the actions, runner. Okay, I need to run the runner, new self-hosted runner, because I'm hosting my own server, which where I want to run these all the things. So okay, so here I have this new self-hosted runner. It is the Linux platform. Okay, now what I need to do is, it is the same thing which we just did right now. Let me just check, did I use this correct version or not? It is the 2.331, and the version which I used is 2.311. 331 and 311. Okay, I'm using the wrong version. Then what I will do, rm-rf, I will remove these all the things, and I will just copy this thing. Okay, so it is already created action runners, and what I will do, I will just copy it here, and I will download it again. Okay, it is downloaded, and it have all these steps. So what I will do, I will just do the validate the hash. Okay, I will follow the same instructions what they are giving. Then it is giving me okay, that is fine. Let me just clear the screen so it will be more clear. Okay, now it is asking me to untar the package. I will untar the package. So Git is providing me all the things. I don't have to study like further things to just run why, like what steps I need to do. So okay, so I have this. Now it is asking me to run this particular command. Okay, I will run this without any delay. Okay, it is asking me to authenticate self-hosted runner connected to GitHub. Enter the name of the runner group to add this. Press enter for default. Okay, default plus press enter the name of runner. Mm, I will just say self Linux, just a simple name. This runner will have the following label: self-hosted Linux x64. Entry any additional label. No, I don't want it. Okay. Enter the name of work folder. Press enter for underscore work. Okay. That is fine. Setting is saved. So we have this agent. Now what we need to do is we need to just start it. So here inside the directory, if I see, we have this svc.sh, and what I will do is I just need to run it, this svc.sh. First of all, stop just for my sake. Okay, must run as sudo, then fine. I will go to the sudo. Okay, okay, so it just stopped my earlier service. Then what I will do, I will do the start. Okay, so right now it is running. Now let me check the status. Okay, so it is currently running, listening to the job. Okay, so if it is running, then it means there should be one runner which should be running right now. So what I will do, I will go to the actions, not this one, setting, action, and then runners. Okay, so I have this self Linux which is ideally running right now. So uh, my agent is running at my server. So what I need to do is I need to do the other work. Okay, so set up the agent who will run the pipeline. Okay, so we are done with this set up the agent. Now let's go for the basics of GitHub Actions. So before doing anything, let's learn what this GitHub Actions is. Okay, so what I will do, I will come back here into my main slide, and here we have just executed this part too. Okay, now coming to the GitHub Actions. This is the pipeline part. Actually, this is the flow which we understood earlier. What the real DevOps process use, like the code push, test, Docker build, push images, deploy, and test. But where this GitHub action will provide me the help. So here, the first thing this GitHub action will watch for me, like this on keyword, when to trigger. So this code push and test, these two things will provide the information to GitHub action that okay, the code is pushed, the code is merged, the test is successful, the test is failed. These kind of output, these two steps will provide to GitHub action. Then GitHub action will check for the instruction that okay, when these things are happening, what instructions are provided to me, and after getting these outputs, what actions I need to run. Okay, so it is the first part on. Now the second part is job. This job is something which will be triggered on this on part. This job is something the what action I need to run step by step. So okay, so let's say if you have just pushed your code and it is in the pending process. So there are companies which are using let's say a dev server. So whenever you are pushing some code to to your master branch, that particular code which you just pushed, like it is in the pending process until the reviewer is not merging it. So what this particular part will do, uh, on it will check okay, it is in the pending state, it is not merged till now, and what actions was configured that I need to run a job to validate whether these changes are good enough or not to be integrated with my main branch. So these kind of things will be handled by the Git. So actually, most of the people are using Git to push their code, and this Git Actions is already integrated in it. So it is easy to use. So this job is something it will do the actions step by step, like this Docker build, this push image, this deploy, this test, like whatever the actions you have configured for this on part, like what are the conditions you are creating for the GitHub actions to do some actions on it. Okay, so it is the pipeline part, like what GitHub action will see and what GitHub action will do. Now let's come to the part. Okay, I guess okay, fine. Now let's go to the now let's come to the part where we are going to see the actual GitHub action YAML. So how this action YAML will look like? It will be created, let's say, wherever is your project. Okay, let me show you. So let's see. It is the same project which we developed till now in the Fast API. And we want to create a GitHub action on it. So what we will do at the base level, like where this project is started, what I will do, I will create a directory here. Okay, new folder. It will be .github. Okay, is it the same? Okay, .github. And inside the GitHub, I will create one more directory that will be called as workflows. Okay, new folder, workflows. Okay, inside the workflows, I need to create a deploy.yaml. It will be deploy.yaml or any YAML, like you can provide any name here. So what I will do, I will just create a new file and I will call it ci.yaml. Okay, so I have this ci.yaml and expected a scalar value, a sequence, or mapping. Okay, so this file is empty. It should not be empty. Okay, fine. So what this particular YAML file will contain? Okay, so let's assume it is a complete one file, and inside this one file we have these three things: name, on, and jobs. This on and jobs are the same which we discussed in the previous slide. So it is the name. So what I will do, I will just put a name here first. Name, name, and it will be, let's say, CI pipeline. Okay. So it is asking me missing property on. Okay, I will provide it. But first, let me explain it. This CI pipeline is something the workflow name is. It can be anything, like whatever the name you want to provide. For the CI means continuous integration pipeline. So you can say it is just not the continuous integration. I'm using it for the deployment too. So I will say CI/CD pipeline. Okay. So now I need the condition on which this GitHub action should perform the actions, like should perform the steps of deployment or any other thing which you want to perform with your code. It might be only with, like, just you want to push the image. That's it. You don't want to deploy it. You just want to push the image every time something is merged at your master branch. So here I have the on. Okay. So what I will do, I will come below. I will do the on. Okay, on. Let's me just, okay. So I don't need the pull request right now. I'm just merging. So I know don't need the condition of pull request. So it is just showing me like what are the options I have. So if I have the push only, then whenever a push happen at your main branch or develop branch, it will start the execution, which is present inside the jobs. And also, whenever you create a pull request, so let's say you modified or you did some changes and you created a PR on it, you created a pull request on it, which is going to merge to the main or to the develop, then it will again create, sorry, it will again start the jobs which is assigned to it. But right now I'm not going for the pull request. Okay, I'm not going for the develop. Okay, and this on should be like this, not in the double quotes. Okay, so here I have the jobs. Okay, so here I have the jobs. So, okay, I have this on push branch main. So I have the on push branches main. Okay, fine, correct. So what are the triggers I can provide? I can provide the trigger pull, sorry, push, which I have right now. I can provide the pull request, which we just saw earlier. We can also provide the workflow dispatch. This is the one which I want you to understand. Go into the Google and try to search it. And this is for the schedule. Schedule is something like you want your pipeline to run in some period, so that you can schedule to here. Okay, okay, I will explain it. This workflow dispatch is something like whenever you create or do some action like this push or pull request, it will create a button at your GitHub action at your GitHub. So whenever you click that button, then only the jobs will execute. That's it. This is the workflow dispatch. You can test it, you can play with it. Okay, so I have this on, I have this name. Now comes to the jobs. Jobs is something in which I'm providing the steps. Okay, so what I will do, incorrect type jobs. So I have this build and deploy is and build and deploy. Okay, so I have this build and deploy. Okay, just let me comment these all the things. So I will use it later. So what it will do, this build and deploy. My main task is just to build the Docker image, because that Docker image is used by my Docker Swarm file, and I want to deploy this into the server which I just configured right now. So it is the tag build and deploy. There are multiple other tags as well. As you can see, this build, only build tag is also there. If I say, This other than build, I have this build and test. This build and test is also there, and there are multiple tags. You need to go and you need to check like what your requirement is. Currently, we are just focusing on building and deployment, so that's why I'm using this build and deploy. So what I will do, I will just remove it, and where it should run, it should run on the machine which we just configured. So for that, what I will do, I will come back here, and as per the statement, this runner will have the following label: self-hosted, Linux, this self Linux, this x64 2, like whatever the name we have provided, but it have will have the following labels too. So okay, so what I will do, I will just use the self-hosted here. Okay, so I have this self-hosted, runs on self-hosted. Okay, so I have these three things. Coming back to this PPT, okay, so I have this build and deploy, but there are few more things which we need to understand. Okay, we understood like this is the workflow. It is my pipeline name. It will have the jobs. It is the jobs, the build and deploy. This job will have the steps. Okay, I have like this multiple step. This is step one, two, three. So if you see, this is the one step. This is the two step. This is the three steps. So each job will it can have multiple jobs too. So like inside the jobs you can have this one build and deploy, you can have this another section as well, you can have the sorry another expression as well, and these are the jobs. Like it will be the job one. If you have this multiple like this build and deploy and then any other thing, then it will be the job one, then another one will be the job two, and inside this build and deploy, these are the steps which I want to perform, like this checkout repository. So why I wrote this action slash command? So there are some inbuilt methods which are called as actions, and there are some raw commands which we want to run. Raw commands like echo, this docker run. These are the commands. These are the raw commands which which can be modified, like which are completely your project based, but there are few commands which will be used in all the projects when you are going to deploy with the GitHub Actions. It is not only for the Docker Swarm, it can be with anything, but these two things will be there, you will find everywhere. So what are those? Those are this. Okay, let me just uncomment it. First, this checkout repository. So what it will do, actually I have configured this for the fast API, my project. And whenever this command will run, what it will do, it will do the git clone on the server where my runner is running. Where is my runner running? My runner is running in this machine, in my local WSL, where I just configured this machine as a runner into GitHub Action. So this machine is configured, and what this action will do, it will do the git clone to that machine. And why we need the git clone? Because we want to create an image, and that image will only be created with the code which we have. So this Docker image creation will require a code, and that code will be cloned by this command. And this command is pre-inbuilt command from the GitHub action. So that is why this particular step is comes under the inbuilt action command. Okay, so it is the one thing. Now let's come to the second. We need to set up Python. No, not set up Python. We need, okay, let me just put the name here, name, and I will say the Docker login. Docker login. Docker login. Okay. What happened? Okay, so this particular Docker login. So anyhow, you are going to create an image, and you need to push this image to your Docker Hub. But how I'm going to push the image to Docker Hub? Like how it is, how we can configure it. So that I will show you. Okay, so it is the command. Again, it is pre-inbuilt. What it will ask for the secrets.docker password, secrets.docker username. But where it will get the secret? Because currently I am nowhere storing any password right now. But my project to run, it needs some passwords. So to do that, what I will do, I will come back here. And what I need to do is I need to come here again inside the setting. You need to go to the secrets and variable. Then you need to go for the action. Then after coming to the actions, you can see this new repository secrets. I already have this Docker password, this Docker username, and you can create your own user like this key and value. This key will be the key you are going to use into the GitHub Actions, and this secret will be the value which you want to store here, and it will be directly accessed from the GitHub to your machine. You don't need to save it anywhere. In this way, you can make it secure. Okay, so it is the one thing. So this thing is clear. Now let's come to the another part. Okay, where it is. Okay, so right now, what I'm going to do is I'm just going to remove these all the things, and we need some other build and push Docker image. Okay, so this is the part where that's why I'm doing the Docker login. So these are the steps one by one which we need to follow manually every time when we want to push a code and to deploy it to the application. But it is just a one-time process. If you are done it, if you just do it one time, every time it will save a lot of time for you. Okay, so it is a build and push Docker. Okay, fine. And where it need to run. Okay, I will just copy it from here. Okay, so it is something new. Okay, let me just close it from here for now. Okay, it is something new. So till now, what we did is we used the uh, already inbuilt keys. That is why I have used this uses. This uses will be used with the keys which are already inbuilt in the GitHub Actions. But right now, I need to run some raw commands. That is why I'm going to use the run. And after it, I have provided the pipe symbol so that it will execute these all commands one by one. Okay, so it will create the image tag, then it will use the docker file dot prod, and then the and it will tag that image with the image tag which it just uh, pop from the GitHub. It is also the variable which is coming from the GitHub, so you don't need to write it everywhere. And it will also make sure that the SHA code of your particular commit is also recorded with each image tag. Like whenever you are going to create a Docker image for a particular push into your master or into your main or for a request, it will take that image. It will take that PR hash code and it will assign it to your image so that your image will also have the record that okay, this particular image came from this particular uh, git pull request or git merge. Okay, so after it I'm going to git push. Okay, that is fine. And then I'm going to use the uh, I'm putting this image tag into the github env. Okay, fine. So it is the one thing. Now let me just verify it. Okay, so one thing is that okay, my image is created. It is also pushed into the Docker repository. But I need to check that whether it exists there or not. So for that, what I will do, I will just put this thing there. Okay. Okay. Fine. So this particular thing will ensure uh, that okay, this image is getting pulled. It means it is available at the um, Docker repository, Docker Hub. Okay, so right now these things are done. Now what I need to do is I need to initialize the Docker Swarm. That is also I'm going to automate it from here. Okay, so it is the part here. Okay, let me just copy it. It will be better if you just do all the indentation at the time only, so that it will be not a headache for you in the later stages, because this indentation is something which will make your code more readable. And initialize the Docker Swarm if not already. So what it will do, it will check for the Docker node. This Docker node ls command will only be run when your Docker Swarm is initiated. If it is not, then it will run the command Docker Swarm init. Okay, so this part is also done. It is just the summary, like which we did all the things manually in the earlier part. That thing we are just providing command here, and we want this GitHub action to do it for me. Now, for my Docker Swarm, I need some Docker secrets as well. Okay, so how I'm going to do that? Okay, so to do that, what I will do, I will again, I have this thing. Okay, so here it is. Okay, so here it is. Ensure Docker secret exists. So what it will do, let's say uh, you have created your if so okay, so let me just explain you this function. So this particular create secret method is something if this particular secret name is not exist at your environment where you are where you are going to run these all commands, then where you are going to run the Docker Swarm. If these secrets, these Docker secrets are not present, then create one. And if it is present, then do not touch it. Why we are not updating every time? Because let's say you have because again it comes to the part of deployment, because when you're going to deploy, what you do is when you have this zero downtime deployment, at that time what you do is you have one running server, you create one another server, or you can say you create one another, you take one another node, you deploy the latest application to the another node. When the another node is working properly, then only you are going to destroy the previous one. And in this transaction, if you are going to delete that particular secret from the node, that it might impact the performance or functionality of your running server, your running application, that we don't want. So that is why we are not deleting any secret. And if you want to update, then in that case you should use the another name, like with v2, with v3, the same secret name, and you need to update in the swarm file too, like here. If I say that this database url, it is coming from here, then you need to update these things here as well. So we need to take care of these all the things when we are upgrading or when we are deploying your application. So currently what this thing will do, it will take all the secrets from, it will check whether this secret exists or not. And if not, then it will create this secret. Okay, so I need these all secrets at my GitHub. So what I will do, I will create one secret for you. So here I have the secret, and what I will do, I will just open it into the another tab. And if I go for the dev deployment in my previous commits, so I have this env.prod, and these are the secrets which I need to import there. I'm putting these all secrets here. It is not recommended. I will say you should not never have this .env file at anywhere into the public repository. Even in your company, you should not push it. Okay, so I have this database URL. I will copy it, and what I will do, I will come here. I will just what are the things? Okay, let me just copy it like this: database URL, and it is its value. This Postgres. Okay, add secret. Okay, so if you see, this database URL is added. So in this way, you are going to create all the secrets in your GitHub. Okay, let me create one more so it will be clear for you. Okay, so here it is. Let me just add the, let's say, Postgres password. Postgres password. And what is that password? That password is Postgres. Okay, add secret. So right now I have this Postgres password too. So I have these secrets and I will create all these secrets. So just, okay. Okay, so all the secrets are added here and I have created the entry for all. Now let's come back here. So this particular task is completed where I want to create the secret for my Docker Swarm. Okay, so we just executed few things and we are making sure that we are going step by step. So this CICD is nothing. It's to understand what step comes first, what step come later into the part of deployment. That thing you have to memorize. You need to understand that what are the dependencies. So one dependency will lead to the another stage, then the another stage will lead to the another stage. So the previous stage is the dependency for the next stage. So in this way you are segregating your CI/CD pipeline work and you create a stages for it to execute. So here what I'm doing here is these are the steps which will be executed one by one. That first you need to clone the repository, then you need to log in your Docker Hub, then you need to build and push your Docker image to the Docker Hub, then you need to pull to verify whether I was able to push the image or not. Then I'm initiating my Docker Swarm, then I'm creating the secrets for the Docker Swarm to be used. Okay, so right now let's do the update compose file. Okay, so here is the one part which is completed. Now let's come for the another part. It is the steps. Sorry, it is the, okay, let me just correct the indentation. Fine. Okay. So what I'm here doing is I'm just updating the compose file with the new image. So if I go to my compose file, so here in the compose file I have the image name. Where is my it is the Redis. It is the fast API ecom backend to the latest, and I'm updating my image to the this name. So whatever wherever this image tags come, it will update that image with the image name which I created earlier in this part. This build and Docker push. Sorry, this build and push Docker image. So okay, so this part is also resolved. So okay, it is good. It is good. So every time, even the CIML have, it might have some different name, but it will use the name which I have provided here. Okay, it is good too. Now it is time to deploy your application because we have prepared all the things. Okay, so it is the command which we need to run. It is the command which we usually run manually, which we executed manually in the previous lectures to deploy our Docker Swarm. And this Docker Swarm was responsible to deploy my complete application. And it is good because what I'm doing here is I'm using this compose prod YAML, which I already have in my repository. This is the stack name. This is stack name from where it is coming. Okay, I guess I didn't provide it anywhere. Okay, deploy stack. Okay, let me just check from where it is coming. Okay, it is coming from nowhere. I will check it. Now, what I need is post deploy verification. Okay, I need the output in the console that okay, my applications are running or not. Okay, it is good. Oh, what just happened? Okay, so my file is completed. Mm, okay, did I miss? This is stack name should be mentioned somewhere. Stack name, stack name. Oh, okay. I didn't provide the env. That env is also required because that is something which I'm going to use every time. This image name and stack name. This stack name will be fast API ecom. Okay, I'm not going to use the stack and the image name. Okay, so it need my username and the workplace. Okay, fine. So I will provide the address where this image need to be pushed. Okay, so it is the Kshitiz 011 and work. But from where I got these details, that is also a part. So it is the Kshitiz 011. Now let me show you the Docker Hub. Okay, so it is the part where we have just configured all the things. We have the secrets.docker username, secrets.docker password into my GitHub. We have this env image tag. This env image tag is coming from here. It is env dot image name. It is env dot image name. Okay, fine. This env dot image name. Okay, okay. It should be tagged as per this. Okay, then I will use the env dot image tag, and this image tag will go. This image tag is coming from here. Okay, fine. And this image name is coming from here. Okay, then it's fine. Okay, fine. Okay, so we have just configured all the things which is required for our one pipeline, and it is really simple. It is not much which we need to do. We just created a server on which this GitHub action will ask to do all the things, and it is the one thing where it will get the instructions. So now let's come to the part where I'm going to see you the Docker Hub repository. So when you are going to log in to your Docker Hub account, if you don't have, then definitely create it. And it is the Docker Hub UI for the free purpose. Like it is the free tier UI you are seeing here. And here you will find two kind of repository. One is public and one is private. So inside the private, I created something as a work. It is my folder structure in the private, and I want to push my image into my private repository. I don't want to make it public because still we are learning here. But although we have created everything for the public, but it is required, like until you have not verified all the things, you should not make it public. So better to first put it into the private repository than make it public. So I want my Docker image to be pushed here. And again, this Docker Hub, where it is, this Docker Hub username and Docker Hub password. So for that, what you need to do is you need to come here and you need to go to the where is this setting? Okay, this setting default privacy. Okay, let me just go here in the private one. Okay, so I have here. Let me just go to the account setting, and inside the account setting, you can see the personal access token. You should not write password anywhere. You need to use the personal access token. So here I have the personal access token. You can create a generate new token. So you can provide the description, you can provide the access, all the things like this public repo read only. So if you create a token, that will work only on the public repos, and if you provide this read only, read and write, it will work on the private repos too. So here I've already created the token. All you need to do is you need to provide the details and you need to click on the generate. Then it will provide you the username and the token that you are going to save inside this GitHub Action Secrets. Okay, so we have done all the things right now, and let me come back here to the structure. So, okay, so we were able to understand the flow of CI/CD pipeline. We have created the agent in which all the things will run. We understood the basics of GitHub Action. We saw the Docker Hub repository, like how it looks. We also created the first GitHub action configuration. Now it's time to work on the zero downtime deployment. This zero downtime deployment is tricky, and but not tricky, it is very easy. All you need to do is just to understand it. So for that, what we need is we need to modify our code. So let's come here, and before merging it to the main branch, we are going to push it to the dev. Then we will do again some changes, and then we are going to merge it to the master. Okay, so what changes we need to do is we need to do these changes inside the compose prod swarm YAML. And what changes we need? So if we see here, we have services like this DB, this backend, this Redis, and this worker. This migrate is completely related to DB. So what we need is we need to work on these three services mainly so that our application will be in a continuous running state. So first, let's come to the backend. Sorry. So first, let's come to the backend. So here, if we see the deploy part, we need to restructure it because currently what it will do, if I'm going to deploy this in a running structure, it will just delete the previous one and again it will initiate a new one, and that is not good thing because it will not provide me the functionality of uh, zero downtime. So for that, what I need is I will just update the deploy structure. So here in the deploy, it will be the updated one. Okay, let me just do the indentation. Fine. Okay, so what it will do? Okay, so we need to focus on this order start first. What this start first means, it will not destroy the previous one. It will start the latest deployment. When it is started successfully, then it will go for the deletion of the previous old one. Till that time, it will continuously let the nginx to serve or to send the traffic to the old one until it is not started. And when the last response is also like when this new pod or container is started, it will let the previous container to finish the process which it is running for the response. When that response is communicated to the nginx, then nginx will transfer the complete traffic to the new backend service, and the old service will be completely deleted. Okay, so this is the one thing. Failure action rollback. If our new deployment anywhere got failed, then what it will do? It will do the rollback. It will just remove the deployment. It will not let it to run like each time whenever if it is not executing, then again it is not trying. Again, it will not try. Whenever it get failed, it will do the rollback. Okay. What it will do? It will do the 10 seconds, like it will give time for the 10 seconds for to start or just to delete the previous one. Okay, so it is the same thing which we are going to do with the worker. So here we have the worker, and we will update the same to the worker as well. Okay, let me just update the deploy section. Okay, so here I have the worker, and again this worker is also a like kind of separate container which is running some service, but again it have some importance. So that is why I'm providing all the properties which I have provided for the worker. And now let's come to the main part, that is DB, because DB is something which should be running all the time, and we need to make sure that uh, it is running. First of all, we need to make sure that it is deployed at the very reliable resource, and it should be running all the time. So we need to deploy one deploy section here as well. Okay, let me remove the DB and make the indentation correct. Fine. So what this deploy means is like where what actions I want. when this DB is deployed, this DB should be deployed at the manager. So this Docker Swarm have this manager and worker might be up, it might be down. It depends like this completely. Like if there are resources, then it is running, and if something bad happens, that worker will go down because all the traffic is coming to that worker. And this DB should be at node which is running all the time. This manager is one who is watching all the workers and have the stable communication with each one. So that is why I'm putting my DB at the manager node. But let's say you have a very large database and you cannot put it into the node. Currently, it is just our basic application. That's why I was able to do all the things into a single machine. But if, say, you have a very large database, then in that case, you must use these services which is provided by the either Amazon or some another cloud services, because they are ensuring you the reliability, and the data is everything for any application. Okay, so these three things we updated, and our ci.camel is good to go. Okay, let's come back here. So we just put the zero downtime deployment, and I explained you also like how it work. That the new container will start for sorry, the old container will be in a running state. The new container will start when a new container started successfully. Then Nginx will route the traffic to the new one, and also it will let the old container to complete the last response which it need to provide, and then it will destroy the old container too. So in this way this zero downtime happen. Okay, now it's time for the deploy application and test. Okay, so we have all the things here, and compose prod.yaml is also here. But first of all, I just want to create a record, so that is why I am putting it into the dev also. uh, okay, so where is my terminal? Okay, so here is the terminal. It is the dev Docker Swarm. So let me just do the git status. So I have this compose and I have this .github. So what I will do, I will do the git add hyphen all. Okay, git commit -m updated GitHub action. Okay, now let me do the git push origin dev Docker Swarm. Oh, sorry. Let me just close it. Dev Docker. Okay, dev Docker Swarm. Okay, so this particular changes are merged there, and now it's time to do the action with the main branch. Okay, so currently everything is fine. Fine. It is with the main branch. Let me just check for the CIML. Okay, let me close it. It is my CIML and it is with the main branch. Let me just check if all the things are present or not there. Fast API e-commerce, dev Docker Swarm 34 seconds ago. So, okay, so this branch is also have all the changes. Now it's time to do the merging with the main. So let's check what is in the main. Main is empty. It is the first commit, so it will not give us any hardship. Okay, so what I will do, git checkout main. Before doing it, let me just open something, Ubuntu, and here if I see this Docker PS, okay, I do not have anything, and this host name -i. Okay, so it is the IP, and if I run this one, will I get anything? I don't think so because nothing is running there. Okay, so this is something which should provide me something. And this IP, it is refused to connect because nothing is running there because no pod is created. Docker ps-a. Let me check if there is any garbage value too. Okay, nothing is there. So what I need to do is right now is need to merge to the main git checkout main and git merge dev docker swarm. So this repository is there. So it must like there should be some action which should be triggered here. Okay, this test check-in is running right now. Okay, fine. Let me see view workflow file. Fine is fine. Build and deploy, it is running. Okay, so we can see all the things here one by one, and we can monitor whether our particular uh, pipeline is running or not. So it was able to successfully push the image to my Docker repository. So let me check and let me refresh it. And here, if I see, okay, this image is there and it was able to successfully pull the image too. Okay, that is running good. Ensure Docker secret exists, run Docker secret. Okay, so there was no secret. Deploy to Docker Swarm. And why it got failed? It got failed with restart condition on failure. Failure, is the spelling wrong? I guess it is the spelling. It is with the spelling on failure. Fine, fine, fine. Okay, so it is the issue with the Docker Swarm. Let me come here and here if I see failure, failure. Okay, I missed one spelling. Again, one typo mistake. Failure, failure, failure. Where is the failure? Okay, here it is. So it is the issue with my sorry, the Swarm file. So what I will do again, I have some check-in, get status, then git add this compose prod Swarm YAML. Okay, then git commit -m syntax resolved. Fine, git commit and then git push. So with this git push again, it should create one another job for me. So let me go back here and not this one, this CICD pipeline. There should be one another. Okay, so here it is. And okay, so if I click on it, it should provide me all the current logs. So it is also providing UI to monitor the pipeline flow, whether it is working fine or not. And you can also get the errors if there are any. And in my case, it was there, so that is why it just showed me like what was the issue. So currently, it is running the deploy. Sorry, it is running the Docker Swarm, and it is the time for test. Okay, and it is good. Post checkout repository and everything is running fine. So as per the completed job, this URL should work now, and it is working. So with our CI/CD pipeline, we were able to deploy a application, and right now it will be deployed automatically whenever I do any change. So it will resolve like it will just reduce so much of time for me in the cycle of deployment. And this is the thing which I wanted to show you with the GitHub Actions. GitHub Actions is really cool. It is providing you a lot of feature. All you need to do is you need to run 2 to 3 commands to just set up it on your server, and then on the go you are ready to do all the things. And also it take a simple YAML language. Sorry, it takes a simple YAML language, so there is no need to learn any another coding like in Jenkins. You need to learn the Groovy, you need to learn the shell to code in it. And still, if you want to learn the Jenkins, then please let me know into the comments, and definitely I will teach you. And that's it for this lecture. and I hope it will resolve some of your issues and it will increase your knowledge base. So, thank you for watching, and let me know if this lecture is fine or any worthy for you. And please share, subscribe, and follow. Thank you.